Now in this video we are going to discuss some examples of NGP. Examples of NGP, neighboring group participation. I'll quote here first example. Example, yes, CH2, CH2 and Cl. Now as you know, there are two lone pairs for sulfur in presence of KOH. It can act as an internal nucleophile. Internal nucleophile. How? This will provide a pair of electrons and this Cl is removed as a living group. So we'll get here a cyclic intermediate. Just one lone pair left. You can find out the formal charge. So the positive charge will develop there. Now from this KOH we have external nucleophile OH minus. So that will attack either here or here. Suppose this is attacking here, this lone pair is going back on the sulfur and we get here our substituted product. So this bond is broken. So here Cl is replaced with OH, but the reaction is following NGP path. First step is NGP, that is SN2, and second is again SN2. So in this way we get the product. I'll write here example number 2. Very popular example of mustard gas. So when mustard gas is treated with KOH, what will happen? So again, instead of CH3, that long group is there, CH2, CH2, Cl. Doing the same thing. So first step is NGP, that is SN2 attack. And we get here cyclic intermediate. Positive. So the OH is our external nucleophile, attacking here or here, one and same thing because both CH2 are identical. Attacking here, that means this bond. If you attack this OH here, you have to break this bond. So you are getting here the product, substituted product, where Cl is replaced with OH. So this is another example of NGP. Now we'll ask third example. So this time I'm using word I will ask because this is somehow tricky. Okay. And SH instead of, I am using S again, but instead of methyl group I attach here hydrogen. What will be the product? Again I am performing this reaction in presence of KOH. What will happen? Again internal nucleophile attacking here on this carbon. You have to remove this, and the first step is NGP because this is backside attack. You remember backside attack. Don't worry whatever may be the structure. That sulfur is here, and listen, it is attacking here at this carbon. H is still there and bearing positive charge. So one H is here, one H is already there. And if I am using OH and if there is no methyl group, instead of that hydrogen is there, then it can abstract that proton in the second step instead of nucleophilic substitution reaction, and we get this product. So this product is obtained. See how because of this proton, if methyl group is there, then we will get this Cl replaced by OH, because there is no chance for this OH. OH is more basic, so it will attack this acidic proton and it is converted back to the H2O. And once it is formed, and this is 5-membered ring, which is quite stable as compared to 3-membered ring. There is less strain, so it will prefer to remain there, and our final product is this one, and not Cl is replaced with OH. Listen carefully, this is because of H. So this is typical example. Again, I can ask one more question. Now, OH and Cl and H. Now, this every time that OH must be toward the opposite side of Cl for backside attack if you want to perform NGP. So this is NGP, this is possible. In presence of KOH I am performing this reaction, and I'll get here this H is there, just like what we observed in the previous case. So now this OH is more interested in H. Instead of acting as a nucleophile, it is acting as a base, because this is very strong base. And then we get this kind of product. We get this kind of product along with H2O. So this is another example. I'll add one more example here, and you try to predict the answer of this reaction. Now, in presence of KOH, what will be the product? Listen, here Cl, which is leaving group, and the internal nucleophile both are toward the same side. And again, there are 2 lone pairs over O and 3 lone pairs over Cl. So there is a repulsion. So this OH is not couplable. This OH is not actually attacking to this carbon. This is not possible because there is repulsion. The position of Cl is not away. It is quite close. So in this case, NGP is not possible. NGP is not possible, but this OH can attack from backside. So external nucleophile is ready to attack. The rate of the reaction will be normal. It is not abnormal. It is not more. So instead of NGP, it will follow the normal SN2 path, and we'll get here this kind of product. So there is actually inversion in configuration. So the arrangement of Cl now was from upper side, and the incoming nucleophile is coming from the downside. So it is following SN2 path and not NGP. For NGP, leaving group and the internal nucleophile must be toward opposite side, otherwise there will be no NGP. It will follow only just SN2. That I wanted to clear here in this example. Thank you so much.